733 float fill. An image is represented by m by n grid image, where image I and j represent the pixel value of the image. You are also given three integers, SR, SC, and new color. You should perform a float fill on the image starting from the pixel SR and SC. And the float fill, what is float fill? We go in four directions. We have the starting point, and we check the top, bottom, left, and right. Return the modified image after performing the float fill. So let's see this example. In this example, this grid is given to us. The starting point is going to be at index 1 by 1, which is going to be row 1 and column 1. So we have this value here. And the value that we have here is the color that we want to get replaced with a new color. So let's say at index 1 and the row 1 and column 1, we have value 1. So are we going to replace all the ones that we have in this grid with value 2 with the new color? No, this is not what we are going to do. It's asking us to do a float fill. What is a float fill? So what I'm going to do, there is a starting point here. I start from here. I go to top, left, bottom, and right, and check if they are equal to this value, this color. Then I'm going to replace them with the new color, and I check the adjacent cells for those new cells and see if they are equal to the color. I'm going to replace them with the new color. As you see here, we started from here, we replaced these four, like these 5 cells, but we didn't touch this one. Why? Because when I check the right cell, it's 0. So when it's 0, I'm not gonna touch this, so I'm not gonna touch the adjacent cell of the 0 as well. So I'm gonna leave it alone. And here I have 0. I'm not gonna touch the adjacent because the value 0 is not the color that I'm looking for. But for this one, I check the top and left, and I see they are equal to 1. So I come here, I check the left and right, and I see they are equal to 1 as well. I check the bottom and top, and I see they are equal to 1. So I'm going to replace this. What I need to make sure here, I need to stay within range. So what is the plan of attack here? What I'm going to do, I'm going to first of all assign the value that I have at index C, SR, and SC to a variable color. So I'm going to assign the color that I am looking for at SR and SC, right? And then what I'm going to do, I'm going to check if at that index the color that I have is equal to new color. I'm going to just new color, I'm going to just return the image. And third, what I'm going to do, I'm going to traverse this grid. How am I going to traverse this grid? I'm going to use DFS. I'm going to have a DFS traverse, and I'm going to check the top, bottom, left, and right? And I check if they are equal to that value, and if they are equal to color, what I'm going to do, I am replacing with the new color, and then I'm going to call this function recursively, and at the end I'm going to return the image as a result, right? So let's see how we can do that. So let's do the variable color first. So I'm going to assign SR and SC to color. Then I'm going to check if the color is equal to new color, and if it is, I'm going to return the image, right? That's it. And then what I'm going to do, I'm going to have a helper function at the index I and j, and what is going to happen here, I'm going to see if the value that I have at index I and j are equal to the color that I'm looking for. I'm going to replace that with new color, and also I'm going to call the helper function recursively for I plus 1 and j, for helper I minus 1 and j. I need to check the four corners, right? So this is the right corner, the left corner, left side, right side, and let's check the top, j plus 1. This is the bottom, and then the top helper. Oh, my bad, sorry. J plus 1, which is going to be bottom, and j minus 1, which is going to be top. So there we go, we're done. But is this going to work? No, because we need to stay within range. And for I plus 1, if I want to stay within range, I should say if I plus 1, so I'm adding the to the rows, right? I plus 1 should be smaller than the length of the image. And if I plus 1 is smaller than the length of the image, then I'm going to call this function recursively. How about this one? I'm going to say if I minus 1 is bigger than 0, then I'm going to call the bigger than, or it can be bigger than 0 or equal to 0, then I'm going to call the helper function for I minus 1. How about this one? For this, I'm going to say if j plus 1, what is the condition? The length of, say, image at index 0, because we're talking about columns, right? And for j minus 1 is going to be, if it is bigger than or equal to 0, then I'm going to call the helper function. So this is how we make sure that we are doing within range, and we don't go beyond the grid that is given to us, right? So now what are we going to do is we are going to call the helper function for SR and SC, because this is the starting point that is given to us, right? And then I am going to return the image, because we are doing it over the image itself. We can just return it after doing the changes, making the changes. And time complexity and space complexity for this solution is going to be linear, because we have to, for the worst case, we have to traverse the whole grid, and the space complexity is linear because we are calling this function recursively. And let's run the code. So I have a thing here. There we go. Thank you.